Okay, hello everyone. We're going to work on looking at a numerical example of mathematical induction. I want you understand exactly what's going on in this problem. I know when we were doing the problems in class, it's a lot like looking at you have all these variables and you're like, okay, what am I really trying to do in these problems? Well, first off, let's start off by understanding what mathematical induction is trying to do. So this is number 12 on page 840. This is the one we didn't get to finish in class. Well, I don't think we finished in any of the classes. But you have this formula, or you have this sequence right here, I should say. And what happens is the nth term of the sequence is represented as n squared. So like the third term of the sequence is 3 squared. The fourth term of the sequence is 4 squared. The fifth term would be 5 squared. And then if I had that sequence, if I added up all the terms, well, it ends up being just this formula right there. And so what happens is someone said, well, this is the formula. But what happened was they were able to prove it. And the way they proved it was by using mathematical induction. So that's what we're trying to do in the problems. What I'm going to do, though, is I want to give you a numerical example of what's sort of going on in the problems. So what it's saying is that, like, let's first do it when, let's not use n equals 1. Let's not use n equals k plus 1. I think that maybe is a little bit more confusing. Let's use n equals 5. Okay, let's use n equals 5. So if you have n equals 5, that means you have the first 5 terms of the sequence. So you'd have the first 5 terms. You'd have the first term, the second term, the third term, fourth term, and the fifth term. Again, fifth term would be 5 squared. And we want to know if that formula works. So if we add up the first 5 terms, would the formula work? So so you can see there's like a question mark right there. So again, I have first, second, third, fourth, fifth term. Does that formula work if I put in 5? That's what we're trying to figure out. So does the formula work? Well, you add up all the numbers. That's 5, that's 6, that's 11. That's how I got all those numbers. You add them all up, you multiply, or you add. The left side is 55. And these 6's cancel out, so the right-hand side is also 55. So the formula works. So hopefully that gives you a little bit more intuition on what's going on. So you have the first 5 terms, and you can see if I add up the first 5 terms on this sequence, it's 55. But if I also use the formula, it also equals 55. Now, what the mathematical induction is saying is, I know it works. Let's assume it works when I have 5 terms. Will it work if I have 5 plus 1 terms? Will it work if I have 6 terms now? Does that formula work? That's what it's asking. That's what the mathematical induction is. That's like that second part of what we were talking about. Okay. Does it work when I have 6 terms? So then we want to say, okay, so let's write the first 6 terms now and see if the formula works. Okay? But instead of writing instead of the first 6 terms, you can see how I write it. The way I write it again right here is I write the first term, the second term, the third term, the fourth term, the fifth term. And then the 6th term, which is the 5th plus 1 term, that's that k plus 1. But another way of saying it is just the 6th term. So you can see here I have the 6th term. This is the 6th. N is 6. N is 6. I just wrote 5 plus 1 instead. So you can sort of just see what is going on there when I'm writing it out. As opposed to writing 6, I'm writing 5 plus 1 because that's the k. K plus 1. So it's like I'm having a next term. Now, does this formula work? That's the question. Well, we know we're going to assume the formula works right here, okay? we assume the formula works. Well, we know it works from up there, but let's assume that it works. Okay? So we're going to put in that same thing we had on the other side. We're going to assume it works when n equals 5. So it's very similar to what we did in class. So when n equals 5, so then when n equals k, so then we put in, here we're putting 5, right? We're putting that exact same formula we had right here. You can see those two things are the same thing. So we're assuming the formula works. So we're saying, well, for the first 5 terms, we think the formula works. And then let's hope it works when we have 6 terms. Okay. We already know it works for 5 terms, but you can see that's what the mathematical induction is saying. The mathematical induction is saying, okay, we think this formula works for 5 terms. Now does it work when I add another term to it? And so we know what this equals right here. We know that equals 55 because we showed that up above. Okay, so then this is like the algebra part now. This is like what we were doing in class, algebra. So but then here it's just numbers, so it's a little bit easier to work with. Again, we knew that this was 55. The next term was 36. And does that equal 91? Yes, it does. So that's what we're trying to do there. So again, it looks a little complicated, but the idea is that you have let's say, just again, this numerical example. You know it works when you have 5 terms. You know it works when you have 5 terms. Does it work now when you have 6 terms? Yes. So that means if you know it works for 6 terms, does it work for 7 terms? Yes, it would. Does it mean if I have any number of terms, would it work if I add another one to it? Yes. That means it works for any number of terms, therefore it is proved that that is the formula. So that's sort of what's going on in the problem. I will post the answer also to number 12, what's shown in the God book. I will post that on Edmodo, so you can see what it is mathematically. But I just want you to understand, at least have some intuition on what's going on these problems. I hope that helped. Let me know if you have any questions. Thanks.